Hi everybody and welcome to this video. On the trail today with the Goat Rocks Volcanic Complex research team. Yeah, in the Cascades. Hannah Shamloo, Kellie Wall, students, other affiliates and associates of this group. There's 11 of us on the Pacific Crest Trail just south of White Pass today. Weather's coming in, but we're going to try to capture what we can. I'd like you to meet this group of people today. That's our humble goal. Maybe a couple of goals with the project itself, but finally giving you a chance to see and meet the Goat Rocks Volcanic Complex research team. Now that's pretty wordy. Thanks for joining us. Let's get started. We're not in the field.
Feels like a dream.
Yes, we are in the field. We're here.
Yeah, I'm not in the lab for a change.
Well, you were up at Mount Baker area or on the Mount Baker project last week.
True. That was really nice.
You're in the zone. Where were you last week and what's the plan this week? Let's start with last week. Who were you with?
Last week I was at Western Washington University with Sue DeBari and Christina Wlowski and Terry Plake from Northwest Indian College.
Okay.
And we were hosting our summer institute. We call it Colshan Summer Institute.
Nice.
And it's a week-long, kind of like a summer camp, but we do pay our participants because they're basically doing small research projects. And the whole point of it is just to explore different ways of knowing.
Yes.
And the main question is, how do we know Colshan or Mount Baker is a volcano? So we take them to the field, we take our participants to the field, we do a couple day trips, look at tephra, we look at lava, we make thin sections. We put those thin sections on the SEM, on the scanning electron microscope. I teach students how to do mineral thermometry and diffusion chronometry, which are the techniques that me and my team use for our science. And yeah, it's a blast. Super fun.
So the last time we saw you, you had just started at Central, basically with one of these videos and just starting with 2 grad students.
Yeah.
They were on that project.
Yes.
And can you synthesize what they were able to do? What were you able to do with them in just 2 years? They're gone.
They're gone. Miss them already. Yeah, so that was Desiree Cunningham and Emily Yoder. Yes. Those were my first graduate students, and they were so awesome. They were responsible for doing diffusion chronometry on multiple lava flows at Colshan. So 4 different lava flows through time, as old as 100,000 years to as young as 9,000 years ago. And the point of their projects and what they found was the timing between the last storage. So think of a magma system that is not just a big vat of boiling liquid, it's instead a mush system. So we have multiple magma storage pods or chambers, however you want to call it. And their job was, what's the timing between that last storage and eruption, which is basically following the magma's ascent path out of the volcano. And that's really useful information because if you pair that with active monitoring, like earthquakes, so if the volcano is shaking or burping or deforming, then that might be indication of that movement of magma. And if we have a stopwatch associated with that, that could be really useful for hazard mitigation.
Yes.
So that's what their whole goal was. And they found that for 4 lavas through Colshan's history, they have a pretty consistent pre-eruptive timescale, which is on the order of weeks to months. So relatively short for that magma from its last storage point to out of the volcano.
And so here we are at Goat Rocks.
Yeah.
Seems like a totally different project.
Totally different project. That's an active volcano, very high threat.
Right.
Here we're at an extinct volcanic complex. But it's Cascades, baby. It matters.
You're killing it. You're doing it. It's really happening. Yes, this is great. Well, thanks. I'm looking forward to learning more about this project in the very early stages.
Early stages. Just got here.
Just got here.
Collecting our rocks.
Right. And so it's you, Kellie Wall, and one of your grad students will be part of this Goat Rocks scene. Her name?
Haley Finch.
Okay.
But both of my grad students are here, Sabrina Ansari and Haley Finch, and I have 2 undergraduates here, Yusei O'Leary and James Gennaro, and these 2 have already been working on Goat Rock stuff with me for the past year.
Okay.
Yeah, they actually just presented their work at GSA in Spokane.
Nice.
Yeah. So I'm happy they're actually here so they can see the lava flows, plural, that they've been working on. Yeah.
Sweet.
Like lighter.
Yeah, we're getting there. We're a thin section. We have called this, what number are we on?
20. We got the 19 yesterday.
Let's just make a pile.
It was great. Just like geologic map of the time record plot. I've got most of it done except for the northeast corner, northwest corner, the southeast corner, and the southwest corner. Go ahead and do some.
Okay, Kelly Wall, USGS. You're no rookie to the Goat Rocks.
That's right.
How long have you been working up here in the Goat Rocks?
Since 2015, so
Almost 10 years now.
yeah, this is, I guess, the 10th year.
Okay. And congrats on this new project with
Thank
Hannah
you.
Shamloo.
Yeah, we're super excited about it. Thankful to NSF.
Yes. I assume it's a continuation of many of the themes in the work that you've already been doing. Is that
Yeah,
accurate?
you could say that. Yeah, they're definitely building off of the foundation that I was trying to put together.
Okay.
And we'll be learning a lot more about the magma storage and timing of things, where I was just defining the basic framework of how this system was built and how long it took.
I see.
And it was about 3 million years, 3.5 million if you count the basaltic volcanoes.
Okay.
Of volcanic history here. And so Hannah and her students are going to be working on figuring out how that developed and how things changed through time. About 3 now, the oldest of the andesitic, dacitic volcanic complex. That was Titan Peak. And then the youngest, we include the Clear Fork lava, Clear Fork dacite, which you can see from the Palisades viewpoint on Highway 12. That's about 100,000. So, yeah, about 3 million years of activity here.
Okay. Is most of this project tied to the earliest days of the Goat Rocks? Am I getting that correct?
Yeah, that's the focus, is
Okay.
figuring out how this thing got started and looking more at the Devil's Horns rhyolite, which I didn't really touch in my project.
Okay.
So I defined the Goat Rocks volcanic complex as the andesitic, dacitic composite volcano complex that was built after that rhyolite unit was in place. So they're going to be working on trying to understand what's the relationship of that rhyolite to the ensuing volcanic complex.
I love it. I'm just getting started, and we're all going to be kind of with this project, hopefully, as it goes from beginning to middle to end. So,
Yeah.
Can we take advantage of this view real quick?
Yeah.
I know you kind of have a little lunch break going.
Yeah, that's
but
okay.
Can you give us some pointers for just the basics of where we are? I assume we're not in the heart of the Goat Rocks complex yet.
Yeah, so we're actually outside the boundary of the Goat Rocks volcanic complex proper, at least as we've defined it as this cluster of composite volcanoes.
Okay.
Right now, we are in the heart of the Hogback Mountain shield volcano. So this was a basaltic shield complex that consisted of 2 separate vents.
Okay.
And this peak that you can see to our left here,
Yep.
that is the lower Hogback Mountain unit. So that was the first vent of this complex here.
Yeah.
Many lava flows erupted from this vent. Some scoria is agglutinated there in this plug. And then we're standing on this hyaloclastite unit.
Mm-hmm.
So all of this fragmental stuff
Yeah.
forms the base of an upper unit,
Okay.
the upper Hogback unit.
Yeah.
And the vent for upper Hogback Mountain is just on that next ridge to the south. I'll point it out here. So there's kind of a thumb like that you can see on the
Sure.
horizon.
Sure.
That is the vent for the younger volcano. And there are hundreds of basaltic lava flows between where we are and the summit of Hogback Mountain.
So it's one of these vents that made those cute little baby columns on Highway 12.
Yeah, exactly.
This guy over here.
It could be this one.
Could be.
Or it could be this one. We're
I
not
see.
sure.
Not sure.
Based on the composition. I need to go check that out.
But White Pass, where I was looking and making that video, is back off that way, kind of down the slope.
Yeah,
Yeah.
to the north of where we are.
Okay.
And we're right along the Pacific Crest Trail here.
Mm-hmm. Mm-hmm.
It passes right over Hogback Mountain.
So most of your work in Goat Rock's volcanic complex has been up and over that ridge.
Actually, I was all over this area.
You were.
So I worked in the core of the volcanic complex, and then also defining the history of these peripheral mafic units
Excellent.
and figuring out the timing relationship and the chemical relationship there.
Sure. How about one more here? You're doing great.
Thank you.
How do you see your role different than Hannah with this project, at least at this stage?
Yeah, I see myself as sort of an advisor, an advisor on the location and the background, the geologic background of the area. So Hannah and her students are coming in as the experts on techniques that I haven't used, like diffusion chronometry, which I'm hoping to learn in my own research as well. But we're kind of combining forces, and I come with the foundational understanding of the geologic history of this area. Hannah's coming in with these new techniques, and hopefully we'll learn some really exciting stuff.
Oh, I'm sure you will.
Yeah, I'm excited.
Thank you.
Thanks.
We're hiking south from the White Pass skiing area. On the PCT, we've met a surprising number of through hikers just this morning, which means that they got to start down in Southern California on the Mexico line, and they are heading to Canada. And this is about the time of year, late August, that the through hikers on the PCT are coming through this portion of Washington. Young people, tired people. I chatted with one of the gals. I said, how can I tell if you're a through hiker versus a day hiker here on the trail? She said, through hikers stink. And she did it with a nice smile on her face. Hi, doing great. You guys are looking strong.
Have a good one.
You too.
I thought they were calling us
Marmot.
there.
No, it's a marmot. You can see him sitting on the rock. It's hard to see, but marmots do that really high-pitched whistle.
Wow. That's the loudest I've ever heard a marmot go.
Good morning, Nick.
Get out more.
John?
and then find a path through the trees, go down around Miriam Lake, and then follow Miriam Creek down into that drainage. So we're just trying to find the easiest walking path here because it's pretty steep, but basically wherever there's greenery, it's a little easier footing. So as good a spot as any. All right, let's ride.
Beautiful point up here and an incredible scree field. Is this all one unit here?
Yeah, this is all part of the lower Hogback Mountain.
It is, okay.
Yeah, the lower unit tends to form these thicker flows, so they form these benches. And the little pond and campsite that we've used above here is on the bench formed by this thick lava flow.
Okay.
So the talus and scree coming down from that is all part of this lower Hogback unit.
So if I scamper and find a slab and bring it over, there's going to be some olivines to look at?
There should be.
Okay.
You can test me.
Let's do it in real life here. I'll just sit tight there.
Okay.
You can just bury me here, okay?
You got a hammer handy, Nick?
Toss my body.
I don't, but let's...
What's this rock?
Yeah, can I borrow your hammer quick?
Pull it out of my pack. There we go.
Thank you.
Yeah. Nice sound. Let's check it out.
If you can do better, that'd be great, but...
Oh yeah, lots of little olivines. There's a big one there. You can see it's kind of greenish or maybe amber.
Yeah,
might be a little
I
oxidized.
see.
And there might be some teeny little plage, but not much.
Okay.
And not much in the way of pyroxene in these rocks either.
Mm-hmm.
Just a lot of olivine.
Is it unusual to have olivine up with the goat rocks, or many of these units? I mean, well, let's take a step back.
Yeah.
So what kind of compositional variety are we talking about with the whole complex?
So the whole complex spans the range from andesites, mafic andesites, up to even rhyolite, so pretty felsic. The mafic volcanoes around the periphery of the complex are mostly basalt and basaltic andesite. Some, like the Miriam Creek volcano below us, has some more evolved andesite, even dacite.
I see.
But mostly in the core of the complex, it's more evolved andesitic to rhyolite, and around the edges more mafic.
So it's so light colored to my eye, like I wouldn't even know this was a basalt if I
Yeah,
was looking at it, I guess.
it is.
Are some of the basalts truly black up here, almost Hawaiian looking, or do they usually have this kind of
They're
altered or
usually
weathered look?
They're usually paler, more gray,
Huh.
especially these thicker flows, because they're so thick they've had a lot of time to crystallize.
I see.
So there's teeny tiny little plagioclase and pyroxenes probably in the ground mass. So what was the liquid part of this magma around all these crystals,
Yeah.
that's the gray part, and it has had a lot of time to cool and crystallize and form this crystalline ground mass.
Thank you. What's the date you have again for this lower unit?
This is about 1.1 million years old.
1.1.
And that's really interesting because it overlaps the age of the Lake Creek volcano and the end of the Bear Creek Mountain volcano. So in the Goat Rocks, the core of the Goat Rocks,
Right.
there were these two major composite volcanoes overlapping, and then Hogback Mountain starts over here. So all at this time, there's sort of like a climactic volcanic event. You have a lot going on in the center, and then this major basaltic shield volcano just
Yeah.
around the edge.
Right, let's keep going. This is perfect. This is, I kind of moved because this is an interesting part of the story to me. So who better than you to ask? What can I visualize here topographically, let's say when this unit is erupting? Do we
Yeah.
have the twin peaks, the two big composite cones, and then this is like a parasitic thing off to the side?
Yeah, not so much parasitic because we're a little too far,
Okay.
but yeah, I mean, you could be standing here, avoiding the erupting lava and see in the distance the peak of Bear Creek Mountain and then the beginning of the Lake Creek volcano starting to form.
So to say it, I'm guilty of just talking about the Goat Rocks volcano as one singular cone
Yeah.
that is now reduced to half its size or whatever.
Yeah.
When you dig a little deeper, it's 2 or even more cones?
There's 4 major composite volcanoes and more smaller events that are part of this complex.
Now we're getting somewhere. Thank
Yeah.
you. Not all 4 existing at the same time.
Right. Yeah. So the 2 that overlapped, I'm going to put this rock down,
You bet.
were Bear Creek Mountain. That was the second peak. And
Okay.
then the Lake Creek volcano. Those overlapped in time. So the end of Bear Creek Mountain was just as Lake Creek was getting started. The other 2, there's a little bit of time between them.
Okay.
But not much for the last 3 volcanoes.
Uh-huh.
There was Bear Creek Mountain, Lake Creek, and then maybe 50,000 years between our ages for the Lake Creek volcano, and then Old Snowy Mountain was the last big one.
Do you know the units that you want to sample?
Yeah, so the objective, Kelly and I have so many questions about this place, right?
Good.
But I think what's the most exciting and what we're prioritizing right now is the fact that we have this entire life cycle of a Cascade volcano
Okay.
exposed thanks to glaciation.
Right.
So what that means is we have the earliest parts of a Cascade's lifetime. So what I'm interested in, what my students will be working on, is let's get basement rocks and also the earliest volcanic products from Goat Rocks, and let's try to understand, does the crust in which the magma is erupting through, does it influence volcanism here?
Okay.
AKA, what kind of crustal conditions are required to birth a Cascade volcano, since we have this really unique record of the earliest parts of its life. So we're out here getting basement rock, and so that includes the Rimrock Lake Inlier.
Here we go.
That's Mesozoic, 160 million year old, dome-like, bunch of different rocks. It's basically accretionary terrain.
And how much do you need to know about that Rimrock Inlet? I mean, it's a
It's a
garbage
mess.
can.
Yeah,
yes.
so that's a great question. I'm still working through that.
Yeah, good.
But so far we have gotten brecciated material, we've gotten some tuffs, but then there's also, of course, sedimentary stuff in there too.
Right.
So this Russell Ranch formation that we're walking on a lot of the time.
Ugly.
And so I don't know what to do with said rocks. I'm going to be straight up with you on that. But we're collecting a little bit of everything because the hope is to get zircon from basement rocks, whatever the host may be,
Okay.
to compare zircon geochemistry to Goat Rocks geochemistry.
Zircons out of the Goat Rocks
Yes.
lavas, compare them to zircons in the
Basement rocks.
And all I know with zircon is just getting high precision dates.
Yes, and that's an important part too, but if you do geochemistry on them, you can look at the trace element behavior, and it can give you insight into how much melting happened, like how much crustal influence is happening in the magma beneath Goat Rocks volcanics.
Hannah Shamloo, are you saying that if I find a zircon crystal in a Goat Rocks lava, it was originally in the basement rock?
Not always, but here's why this is cool. The work that Kelly's done for her dissertation, she's done, a ton of dating on a bunch of units in the Goat Rocks and some in the basement rocks. And what Kelly's seeing in her volcanic zircons is, one, some of them are old as these basement rocks. Some of these zircons might be inherited from these basement rocks.
Okay, you're blowing my mind. I
It's
had no
cool.
idea. I thought everything in the lava would be the age
Just
of the
concise. I mean, normally yes, but no, those magmas underneath the crust,
Okay.
depending if they're melting the wall rock or if they're passing through something, they can grab crystals or crustal chunks, we call them, xenoliths. They can grab those and then we can sample them, and that gives us indication that yes, these magmas are indeed influenced by their surroundings, which is not a new concept. I'm not changing the
Right,
game here,
right.
but it's just I'm interested in what that looks like for the beginning of a Cascade's life.
So how thorough does your inventory need to be with all of these basement rocks that are pre-3 million years? There's a lot of possibilities.
There's so much stuff out here. So, okay,
Right.
yeah, I talked about the Rimrock Lake Inlier. That's Mesozoic. But then there's these Eocene basalts that you've talked about on your channel.
Basalt of Summit Creek, baby.
Basalt of Summit Creek, baby. So we got a bunch of those. We got the Discovery Creek basalt. And then we have the Ohanapakash formation. So that's like a volcanic clastics material that we think represents some of the earliest Cascade volcanic,
Yes.
like 30 million years
In
ago.
the
So old
30s,
stuff,
right.
being deposited in a submarine basin. So yeah, got some of that too. Got some Eocene basalt.
You're covering your bases.
We're covering our bases. I would like to send everything off for geochemistry, for some whole rock and trace element geochemistry. But really, I think the first goal is zircon for those trace elements.
So is there a sharp, very clear goal for visualizing the earliest days of the Goat Rocks event? Like, are you trying to come up with a story and you've got 5 options for what the story might be when this whole thing gets started?
I haven't thought that far ahead, but I think initially I just want to let's get chemistry on basement, let's get chemistry on volcanics.
Right.
Kellie has chemistry on mantle-derived, so mafic stuff, so
Okay.
that's kind of our mantle part of the story. We take all 3 of those parts,
Yeah.
and you can model, if you have mantle composition, you have crustal composition, how much do they have to mix to make the volcanics that you see at the surface? So that's kind of the end goal, is like how much mixing, how much melting, how much crystallization is happening before these magmas erupt.
Okay, I'll add one more.
Yeah,
Does
please.
that have anything to do with hazards then? If we're in the earliest days of a volcano, are you selling this with some sort of public safety component?
Absolutely. So long-term goal, which we won't achieve, it'll take a while to achieve this, okay? But long-term goal is, if we understand the beginning, if we understand the end, can we extrapolate that to, say, an active volcano like Mount St. Helens, who's relatively young, right?
Yeah.
She's a teenager. She's in her mid-days. So can we get some sort of insight into how Cascade volcanoes change through time?
Right.
And when do they start waning?
Right.
When does their activity wax? And
Yeah.
ultimately, yes, that's the goal. Can we compare this extinct volcanic complex to something that's active and that we're monitoring?
As we walk back to the Cheetos, or what is it?
Oh,
chip?
yeah, I got the Lays going on
Okay,
today.
no Funyuns today?
No Funyuns.
You know, I was taught a generation ago that the earliest days of a Cascade volcano is just nothing but a shield volcano, and then it evolves and becomes more and more silicic as it goes along. Is that total baloney?
I think it's probably true for some, but here is cool because before Goat Rocks was this potentially caldera-forming eruption that was highly silicic. So we're getting a rhyolite.
At the beginning?
Yeah, so we're getting a bang to kick off the Goat Rocks, which rhyolites are known to be rare in the Cascades. So another question Kellie and I have is why? Why rhyolite first?
Right.
Mount Baker is maybe the only comparison that comes to mind that also started with a rhyolite. It
Right.
has the Colchian caldera a
Yes.
million years ago. So yeah, that's also an outcome of this project is why are we starting with a rhyolite?
Thank you.
Thank
Back
you.
go. You're good.
You're good. Go team.
Yeah.
Do you think you end up ever teaching a 101 lab?
I want to hear
Not
you
for that
chewing
reason,
on
I
your
don't think,
potato
but-
chip.
Oh yeah, I forgot I'm mic'd.
Probably at some point here.
See ya.
Yeah.
Come eat lunch with me.
Oh, she eats chips like I do. Wow, that's
she's a beast.
Thanks everybody for joining us with this Meet the Goat Rocks team. It was really just Hannah Shamloo and Kellie Wall for this video, and I think we'll eventually get to know the students a little bit better. Jordan Carey behind me here with Fuji the dog. And Jordan and I are heading back to the car, but I have a few lingering thoughts as we've been just chatting out loud about certain things. Let me flip you around. I mean, this is pretty good Cascade scenery here. So here are some of my thoughts as the Goat Rocks team continues to work down below us. Why are these vents so prominent? Apparently that's a thing up here, that in the Goat Rocks volcanic complex and even peripheral to that, these vents are giant thumbs that are sticking out here and there. I don't know the answer to that. I'm intrigued by that. I'm swinging you now to the east, looking down at Rimrock Lake. I think Jordan and I remembered our little lecture we got from Kellie and Hannah. We think that's Round Mountain. I'm sure if you viewers will correct me. Those two things, Twin Peaks possibly, that Spiral Butte. And if I can zoom in, I think we're looking north to the top of one of the ski lifts at White Pass. And the Pacific Crest Trail right up in here that we will take back to the car. So my open questions, which I will learn from the research team or learn from you or other things as well, is that as we look at this beautiful old map from 1960, and here's Mount Rainier, and here's Rimrock Lake, and here's Hogback Mountain, and that's where we are today. We're looking, I think I'm going to title this thing, the Hogback Mountain Basalt. And the thumb I just showed you is one of the two main thumbs, or the two main vents, for two major Hogback Mountain basalt flows that flowed north down to the White Pass area. And you remember those cute baby columns I was showing you in the previous video called White Pass Outcrops? These are the two vents, man, just beyond Jordan. That's one of the vents of the Hogback Mountain basalt eruption. Again, the baby columns down along Highway 12 came from here. The lava came from here. Or it came from here. I think Kelly had the date of about 1 million years. Is that right? I think she said about roughly 1 million years for these basalt eruptions. So my other question, which I'll just pose looking off in this direction, I'll flip you around. I mean, I know we're at Goat Rock's volcano area, but why can't all of these 1 million year old basalt vents be part of something more regional? The Boring volcanic field, which I know almost nothing about, extends, I think, from as far south as Bend, Oregon to as far north as Yakima, Washington, and maybe beyond. And as I understand it, many of those cinder cones, basaltic, and shield volcanoes, like these two vents, are coming up along a network of normal faults. So even Spiral Butte, man, Jordan, just that Spiral Butte thing, I think is part of that story. Boring, I think, the Boring volcanic field, but I don't know. Is it that simple? Anything younger than, anything that's ice age, that's basaltic, that's been mapped on a normal fault with a regional network, can you tie it to this Boring volcanic field? I don't know. I'm sure I'll get some help from some of you. I don't know if we will get into the Boring volcanic field this winter, but it's a thought that I've had here. I have to flip you around one more time. This is so good up here. I'm not in Idaho today. These are the Cascades. This is Cascade scenery in late August of 2024. And as the marmots whistle and the pikas chirp and the dogs wait patiently to return back to the vehicle, I say, thank you, I love you, and goodbye from Hogback Mountain near the Goat Rocks volcanic complex. It is gorgeous stuff, and it is everywhere. And every block is a little bit different. Vesicular stuff. This almost looks Hawaiian to me. You got these blocks soldered in. So you guys are through hikers, huh? All the way from Mexico? Wow.
Yep, it's been a long journey. I'm pretty tired. I'm gonna make it. We've just got some moleskin on our pads. Pumping it out.